Well, hello again, everybody. Here's the plans for the day. What I've got going is I've got two different videos going in this one. All depends on the day and the year. Some years I split up the implicit derivative, other days I don't. So, long story short, if you're watching a video for the second part, that would be my chamber singers that's going to miss in 2014. What you guys will need to do is fast forward to example 8. You would have already seen all the other items. If you're watching this for the first part, you need to make sure that you have your note sheet in front of you, and then just hang with me because this day is quite a bit different. What I do is I talk about the implicit derivative today in comparison to the explicit derivative. So I'm going to jump right into kind of the lesson. I've got on this first page, if you're watching this because you missed the first part, the next few slides have the answers to that worksheet that we had. 4.3, second part. You can always, they're on Moodle, and you can also pause this and look at them if you need. Otherwise, I'm just going to fast forward through them so that I can get to the main part of the lesson. Here comes the main part of the lesson. This part is not on your class notes, but hang with me one second. The key today is we're going to find the derivative with respect to x. Something you've already been doing. But I spoiled you so far. Every equation that you dealt with so far has been what we call in explicit form. Explicit form means that it's solved for a variable. It's solved for y, it's solved for f of x, it's solved for h of t, it's something equal, and then there goes your equation. What I need to get you through today is I need to show you what it looks like if something's written implicitly. Implicitly means it's not solved for a certain variable. This will show you some different graphs. If you notice on your graph sheet, we got circles, we got ellipses, we got some weird looking graphs. It gives us the power to look at those today. So part of our steps is the same. When you find the derivative of something explicitly, well, my notation, this is really important today. When I take the derivative of 1y, its derivative is 1 dy dx. And then when we find the derivative of the others, it's 6x plus 5. A lot of our equations we can make into explicit form by trying to solve it for y. But some of them get really, really ugly if you try to do that one. Like if you solve this for y, you would get 12 minus 2x squared minus x all over 8x. And then we would have to use the quotient rule to find that derivative. I have a better way I'm going to show you here in a little bit. So hang with me. Here's kind of the main part of the day. If you find the derivative of something that has an x in it, it's just like what we've been doing. The derivative of 7x to the fourth is going to be 28x to the third. So nothing new there. Here comes the new part, though. If you find the derivative of a y term, you're going to do it like we've been doing. Use the power rule, use the product rule. This derivative is going to be 36y. But once you find it, you put dy dx behind it. It's a shortcut, so you don't have to solve the equation for y to get it by itself. So find the derivative of something with respect to y, put dy dx behind it. Here's 6x squared. Well, its derivative is going to be 12x. Plus, the derivative of 3y is going to be 3, and then dy dx. That's going to be the main thing today. So look over at your first example. I'm going to show you two ways to solve this problem. I would like to find the slope of the tangent lines at the point 3, 4. I've already come in and drew these lines in. And also negative 3, 4. I'd like to find those slopes. On the left-hand side here, you don't need to worry about writing this one down. On the left-hand side, I'm going to show you how we would handle this explicitly. Explicitly, you would have to solve this thing for y. And trust me, this is one of the easier ones we would do. So if I solve this thing for y, I'd have y squared equal 25 minus x squared. I would take the square root of both sides. So there's what y would be equal to. Now I need to find the derivative of this. So the derivative would be dy dx would be, here comes the chain rule, 1/2 25 minus x squared to the negative 1/2 times negative 2x. So simplified, here's the derivative. Dy dx is going to be 1/2 times negative 2. So I've got negative x over the square root of 25 minus x squared. That was an easy one. Now, I would like to evaluate dy dx at the point 3, 4 and at the point negative 3, negative 4. Oh, I'm sorry, negative 3, 4. Well, what I'm going to do, plug in 3 wherever I see an x, so I've got negative 3 over. Plug in a 3 down here, that's going to become 25 minus 9, which is 16. Square root of 16 is 4. So boom, I know the slope of this line right there is negative 3/4. If I plug in negative 3 here, the opposite of negative 3 is positive 3. Plug in negative 3 down here. 25 minus 9 is 16. Square root of 16 is 4. I know the slope of this one right there is positive 3/4. That's what it would look like explicitly. Let me show you what it would look like implicitly. I'm going to take the same thing, x squared plus y squared equals 25. I'm going to find this derivative with respect to x. So it's going to look like this. The derivative of x squared is 2x. The derivative of y squared is 2y. But since I found the derivative of the x, I'm going to plug dy dx behind it. And then the derivative of 25 is 0. Now I'm going to solve this thing for dy dx. I'm going to move that 2x to the other side. I'm going to divide by 2y. So here's dy dx. It's the opposite of x over y. A little quicker than over here. Now when you want to find the slope of the tangent line, let me find it at 3, 4. Just says this. Plug in a 3 wherever you see an x, so I got negative 3. Plug in a 4 wherever you see a y. So boom, I got negative 3/4 for that one. And if I do my other one, negative 3/4, plug in a negative 3, I'm going to get 3/4. So there's what it would look like implicitly. Implicitly means finds the derivative, and then plug in dy dx behind it. Here goes our next one. I'm going to find the derivative of 3x squared plus 8y squared equal 84. I'm going to be finding the slope of the tangent line of this. Like I said, I've already come in to save a couple of minutes and drew that in. So the derivative of 3x squared becomes 6x. The derivative of 8y squared becomes 16y dy dx, because I took the derivative of a y term, equal 0. Now I'm going to solve this thing for dy dx. So I've got negative 6x all over 16y. I'm going to go ahead and reduce that. 2 goes into both of them. So I've got negative 3x over 8y. There's dy dx. I'm now going to evaluate dy dx at the point 2, 3. I'm going to plug in a 2 for my x and get negative 6. I'm going to plug in a 3 for my y and get 24. So the slope of my black line up there will be negative 1/4, which looks about right. Now hang with me on number 3. Number 3, the game changes just a little bit. Because notice I have an x and a y term together. When that happens, you get to use the product rule. So here's what it's going to look like. The derivative of x cubed is 3x squared. Here's how we're going to attack the derivative of negative 5xy. I've got negative 5x times y. Here's my first term. Here's my second term. So the derivative of my first term is negative 5 times my second term, which is a y. There's no dy dx yet because I did not find the derivative of that. I just used it. So I went the derivative of that times that plus the first term, which is negative 5x, times this derivative, which would be 1 dy dx. So I've got negative 5x times 1 dy dx. And I'm going to set that equal to 0 because that's the derivative of 19. Now we're going to solve this for dy dx. So hopefully these steps will make sense. The 3x squared is going to come over here and become negative. The negative 5y is going to come to the right and become positive. And then to get dy dx by itself, I'm going to have to divide by negative 5x. So here is dy dx. Negative 3x squared plus 5y all over negative 5x. Now let me figure out the slope at the point negative 1, 4. If I plug in a negative 1 wherever I see an x, and a 4 wherever I see a y, I'm going to get negative 3 plus 20 all over 5 makes the slope of this line right here 17/5. So the trick part there was a product rule. Don't worry, on number 4 I also have a product rule. So here's your number 4. Notice this cool looking graph that we're going to work with. Never have you been able to work with a graph that looks like that until now. So here's number 4. The derivative of x cubed is 3x squared. The derivative of negative x times y will be the derivative of the first, negative 1, times the second, y, plus the first, which is the opposite of x, times the derivative of the second, which will be 1 dy dx. So there it is with the product rule. But notice that there's a plus y squared that shows up now. So now I got plus 2y, and then another dy dx. And we're going to set that equal to 0, because that's the derivative of 4. I'll go ahead and do all the steps on this one. I'm going to move the 3x squared to the right and the negative 1y to the right. So I'm going to have this so far. I'm going to have negative 3x squared plus 1y. But notice over here I've got the opposite of x, dy dx, plus 2y, dy dx, as I run out of room. To solve this thing for dy dx, I'm going to factor out a dy dx. That way you only see one of them. If I do that, there's an opposite of x plus 2y left over, equal negative 3x squared plus y. To bring this thing home, I'm going to divide both sides by the opposite of x plus 2y. So I've got negative 3x squared plus y all over the opposite of x plus 2y. And then to find the slope of that, dy dx at the point 0, negative 2, when I plug those numbers in, I wound up getting 1/2. You're good with the calculator, so you can run those through also. So there's my number 4. That's pretty much what I'm going to do to you until I get to number 8. So I'm going to quickly go through number 5. Number 6 and number 7, we're going to write the equation of the tangent line, and then I'm going to start tossing some fractions in front of you. So here goes my number 5. The derivative of 3x squared is going to be 6x. The derivative of 8y squared is going to be 24y dy dx. And then here comes the product rule with 3xy. The derivative of the first is a 3 times the second, which is a y, plus the first, which is 3x, times the derivative of the second, which is 1 dy dx, equal the derivative of 58, which is 0. When I solve this thing for dy dx, to the other side goes the 6x and the 3y. You can skip this step if you see what we're going to do, but now if I factor out a dy dx, I'm left with a 24y plus 3x. And then now that I test this and it's on a video, let me backtrack. Hopefully you caught it also. This way back here should have been a 16y. Sorry I hit for not using my answer key. So that means this number right here is also a 16y. So that when I solve this thing for dy dx, I got negative 6x minus 3y over 16y plus 3x. And I'm not going to worry about running the numbers through because I'm sure you could do that. Now, number 6 is the hardest one on the worksheet, I think, because it's kind of got a trick in there. So here's number 6. Here's what we'd like to do. It says, for problems number 6 and 7, write the equation of the tangent line at the given point or points. Well, remember the steps when you want to write the equation of the tangent line? Step number 1, you got to find the derivative. Step number 2, you got to evaluate the derivative at that point. So we need to find dy dx of 1. And there might be another point show up, we'll see. And our third step, we use y equal mx plus b to bring it home. So all depends on what you want to do first. Some things that I know, since I'm given at x equal 1, at some point, I'm going to have to go find my y value. I can do it now, or I can do it in a little bit. I might do it here in a second. Let's go ahead and get the derivative of this thing. The derivative of x to the 4th is going to be 4x cubed equal the derivative of 64x squared, 128x. The derivative of 63y squared, negative 126y dy dx. And then now let's solve this for dy dx. So dy dx is going to be 4x cubed minus 128x all over negative 126y. So there's my derivative. But notice I need my x value and my y value. So I need to plug in 1 into this original equation and go get my y values. So it's going to look like this. I'm going to plug in 1. I might just do that work over here. So I got 1 to the 4th, so I got 1 equal 64 times 1 squared minus 63y squared. And I need to solve this thing for y. So let's subtract away 64. So I got negative 63 equal negative 63y squared. Divide both sides by negative 63 and get 1. So looks like I'm going to have 2 different y values. When x is 1, y could be 1. When x is 1, y could be negative 1. So 2 different points showed up, which makes sense if you look at the graph. When x is 1, I've got 2 different values I could work with. So here goes. Let's evaluate dy dx at the point 1, 1. And when I did that, when I ran it through, I had 62 63rds. So that's my slope. Now let's use y equal mx plus b. So I've got 1 equal 62/63 times 1 plus b. Since I don't like touching my calculator, I'm going to think of 1 as 63 over 63. So that when I subtract 62/63, b is going to be 1/63. So one equation is y equal 62/63 x plus 1/63. Woo! What did you just find? The equation of that line right there. Here comes the second one. I need to evaluate dy dx at the point 1, -1. And when I did that, I got negative 62/63. I'm sure you just take my word for it. And then when I went to solve this, I had -1 equal. Well, 1 times negative 62/63 plus b. B was positive, so b is going to be negative 1/63. So here's that equation. Y equal negative 62/63 x minus 1/63. You just found that equation. Number 7's like it, but it's a lot easier. There's just one line on that one. So on to number 7. The derivative of x cubed looks like 3x squared. Here comes the product rule with 7x squared y. So the derivative of the first piece would be negative 14x times y. Now I got to do the second part, plus the first, which happens to be negative 7x squared, times the derivative of the second, which would be 1 dy dx, minus the derivative of 6y, 6 dy dx, equals 0. Now let's solve this for dy dx. So here goes my thinking. The 3x squared's got to go to the other side using subtraction. The negative 14xy's got to go to the other side using addition. And it's going to be over negative 7x squared minus 6. I shortcutted that. I would have factored out a dy dx and then divided both sides by it. Now I need to go get my y value when x is 1. So let me plug in a 1 into the original, not the slope yet, because I don't have a y value. 1 cubed is 1, minus 7 times 1 squared times y, minus 6y equal 27. I now have negative 13y equal 26. So y must be negative 2. So we're going to write the equation of the line at the point 1, negative 2. And when I run a 1n for x and a negative 2n for y, I'm going to get negative 3 minus 28 over negative 7 minus 6, negative 13. So my slope is going to be positive 31/13. I saw 2 negatives make a positive. To bring it home now, negative 2 equal 1 times 31/13 plus b. And when I subtracted 31/13 over, you're going to get negative 57/13. So the answer, y equal 31/13 x minus 57/13. Now depends on the year. Most of the time we would have stopped at this point. This ends part 1. So part 2 will start right after this. So all depends. If you're one of my finger center people that miss, you'll be starting right here. So here goes. The steps are going to be the same as what we did last time, except for some fractions are going to show up. You have a lot of leeway on how you solve this. So here goes your number 8. I'm going to find the derivative of x to the 1/2 plus y to the 1/2 equal 9. And then we're just going to find the slope at the point 16.25. Well, let's find the derivative of this. So I'm going to have the derivative of this is going to be 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 dy dx equal 0. Now you got a lot of leeway. You just got to get dy dx by itself. So here's a couple of different ways, but one way to get dy dx by itself, you're not allowed to leave a fraction within a fraction. You can have it there for a minute, but then you got to simplify it. So check out what's going to happen. I'm going to subtract this piece over. So I'm going to have negative 1/2 x to the negative 1/2 divided by 1/2 y to the negative 1/2. There's what I got so far. Well, negative 1/2 over 1/2, those are going to cancel out, leaving me negative x to the negative 1/2 over y to the 1/2. Here's a negative exponent, so leave your negative alone. Put this x to the negative 1/2 on bottom. Put the y to the negative 1/2 on top. So here's your dy dx. It's going to be the opposite of y to the 1/2 over x to the 1/2, or square root of y with the negative out front over the square root of x. That's one way. If I want to evaluate this now at the point 16.25, I'm just going to plug those numbers in. So it looks like I'm going to get negative 5/4. That's one way. If you didn't like that way, you could have, you backtrack the video if you needed to pause that and write that down. Here's what I did on my answer key. I don't know if you would have saw this or not, but I didn't like the fractions. So I decided to get rid of those fractions right off the bat. So I decided to multiply both sides of this equation by 2. And that's fair game because I'm doing it to both sides. Well, if I do that, I'm left with x to the negative 1/2 plus y to the negative 1/2 dy dx equals 0. And then when I solve this thing for dy dx, I have the opposite of x to the negative 1/2 over y to the negative 1/2. And then I put this on bottom and that on top. So I have the opposite of y to the 1/2 over x to the 1/2, or the opposite of the square root of y over the square root of x. Either which way you get the same answer. Moral of that story, you have different ways to solve this now. Here comes your number 8. Let's go find this derivative. So the derivative of 3x squared is going to be 6x. The derivative of 5 over y, I'm going to think of that as 5y to the negative 1. The derivative of that is negative 5 over y squared dy dx equal 2, because that's the derivative of 2x, plus nothing. Now we're going to solve this thing for dy dx. So here's the best way. I'm going to have negative 5 over y squared dy dx equal 2 minus 6x. So I subtracted that 6x over just like we've been doing. Now, to solve this thing for dy dx, though, I'm going to multiply both sides by this reciprocal. I'm going to multiply both sides by that reciprocal. Now what happens here? This is out of here, leaving me dy dx. And then what am I going to wind up with on the other side? Well, I'm going to have a 2 minus 6x times negative y squared all over 5. You can leave it like that. You could bring this y in front. You could distribute that y squared if you want. It doesn't really matter because now we're going to run the point 1, 1 through that. And when I run the point 1, 1 through there, 2 minus 6 is going to become negative 4 times 1 squared is 1 times negative 1. So I got times negative 1 all over 5. The slope becomes 4/5. But this is the main part. If a fraction shows up, we got to get rid of it. Now let me show you on here what you can't do. You can't do what we did when there was no fraction showing up. You can't say, okay, get dy dx by itself. It's going to be 2 minus 6x over negative 5 over y squared. If there's a number involved, you might get the right slope, but you can't leave a fraction within a fraction. You would have to simplify that. So just get rid of that right off the bat. Here's my number 10. I got to make it a little bit harder for you, of course. Number 10, the derivative of 5x cubed, 15x squared. The derivative of 3 over y squared, I'm going to think of that as 3y to the negative second. That derivative becomes negative 6 over y cubed dy dx. Plus the derivative of 4y, 4 dy dx. The derivative of 12, 0. Here's what you cannot do. You can't do this. You can't say dy dx is negative 15x squared over negative 6y cubed plus 4. You're not going to do that because that puts a fraction within a fraction. It's not mathematically correct. And notice there's no number left here. Here's how you have to handle this piece. Get rid of anything that doesn't contain a dy dx. So I'm going to move that 15x squared to the other side and make it negative. Do like we did before. I'm going to factor out a dy dx, which leaves me negative 6 over y cubed plus 4. Now you can't divide by that yet because that would be a fraction within a fraction. What you got to do now is get a common denominator with this piece right here. That way we can invert and multiply. So here's what it looks like. dy dx out of negative 6 over y cubed plus 4, my common denominator is a y cubed. To go from this y cubed to this y cubed, I don't need anything with the negative 6. But to go from this denominator of a 1 to a denominator of a y cubed, I need to multiply by y cubed. So I'm going to have plus 4y cubed equal negative 15x squared. Now watch what happens. To get dy dx by itself, I'm going to multiply by this reciprocal. So I'm going to have negative 15x squared times the reciprocal of this, which is y cubed over negative 6 plus 4y cubed. And the final answer is going to look like this. Negative 15x squared y cubed over negative 6 plus 4y cubed. There's dy dx. Notice that there's no fraction within the fraction. And don't worry, I got two more coming your way. If you're good, you're welcome to pause the video and get rolling on the assignment. If you're not good, watch what I do on number 11 and 12. So here goes number 11. The derivative of 3y squared is going to be 6y dy dx. The derivative of 7 over y. I'm going to think of that as 7y to the negative 1. So that derivative is negative 7 over y squared dy dx. The derivative of x squared is 2x. The derivative of negative 6x is negative 6 equal 0. You got a fraction, so here goes. 2 to the other side goes. That positive 2x becomes negative. That becomes positive. We're going to factor out the dy dx. And that's really off. We're going to factor out that dy dx, which leaves a 6y minus 7 over y squared. Like I said, you don't get to use negative exponents. You don't get to leave that fraction within there. So next step, I'm going to get a common denominator, which is going to be a y squared, because this is over 1. To go from a 1 to a y squared, I need to multiply by y squared. So I've got 6y cubed. To go from here to here, I don't need anything, so minus 7 equals negative 2x plus 6. Now to bring it home, I'm going to multiply both sides by the reciprocal. So it's going to look like this. I'm going to have negative 2x plus 6. Notice that I'm putting those in parentheses because they belong together. Times y squared over 6y cubed minus 7. So I multiplied by that reciprocal. And then I multiplied straight across if I could. So I just put that in parentheses, times it by y squared, over the 6y cubed minus 7. And then there's no points to evaluate it at, so that's going to be that. And then my last one. Now, if you look ahead on this one, the number of dy dx's we could have, 1, 2, 3, 4. So here goes. The derivative of y cubed, 3y squared, dy dx. Derivative of y squared, 2y, dy dx. Here comes the product rule. The derivative of the first times the second plus the first times the derivative of the second. And then here's the one that's going to make me work. The square root of y, so I'm going to think of that as y to the 1/2. Its derivative is 1/2 y to the negative 1/2. So I'm going to put it down there, dy dx, equal 0. So there's what I got so far. Now we got to combine whatever we can. So I'm going to move that negative 5y to the other side, so it becomes 5y, because that's the only thing I get to get rid of. Let me take out a dy dx, just like we've been doing. So I've got a 3y squared plus 2y minus 5x plus 1 over 2y to the 1/2. To bring it home now, get a common denominator. My only denominator is 2y to the 1/2. These are all over 1. So to go from here to here, I need to multiply by 2y to the 1/2. So 3y squared times 2y to the 1/2 is going to be 6y to the 5/2 plus, looks like I need to multiply the 2y by the 2y to the 1/2. That's going to be 4y to the, add your exponents, 3/2 minus 5 times 2, so I got 10 x y to the 1/2. And then to go from here to here, I don't need anything. Equal 5y. Oh boy. For the final answer, I'm going to multiply by the reciprocal. So I'm going to multiply by 2y to the 1/2 over all of that. Well, 5y times 2y to the 1/2 is 10y to the 3/2 over all of that. 6y to the 5/2 plus 4y to the 3/2 minus 10xy to the 1/2 plus 1. And there we got it. So there's the lesson. The key thing there, guys, if a negative exponent shows up, you can't use it. If a fraction shows up, you can't leave it within your answer. So more algebra. Notice the calculus step was the first part. The rest is our algebra. So good luck finishing that up. What do you have going? You need to finish that worksheet that we have. That'll be the last 5 or 6. And then there's a math Excel assignment with 10, 11, 12 problems on there. I can't quite remember. But that's what you'll need to have done for next time. Good luck.